Okay, so today we're looking at trig reductions, numerical examples, but now with non-special angles included. So just a quick reminder about your co-ratios. Remember, we said that if we had the sine of 90 minus theta, this 90 would change the sine into cos. And this would be cos of theta, and the cos of 90 minus theta would be the sine of theta. Okay, so we used those over the last couple of days. Right. So if I had, say, the cos of 20 degrees, that would be the same as the sine of 90 minus 20. Remember, the thetas have to be the same. So that would be the sine of 70. So the cos of 20 is equal to the sine of 70. Say I had the sine of 40 degrees. Okay, so I could say, well, the sine of 40 is the same as the cos of 90 minus 40. The thetas have to be the same. So that would be the cos of 50. So when we have non-special angles, if you have two angles that sum to give you 90, like 20 and 70, there we have, or 25 and 65, okay, 40, any two angles that give you a sum of 90, then we can use co-ratios. So we're going to replace, if we had, say, cos of 20 divided by the sine of 70, those are not special angles, so I can't use a special angle triangle, but I can see in my sum that these equal 90. 20 plus 70 gives me 90. So I replace one of them with a co-ratio. So I'm going to write the sine of 90 minus 20 at the top over the sine of the 70 at the bottom. So we replace one of them. And that's going to give you sine 70, 90 minus 20 is 70, over sine 70, which is equal to 1. Because we could divide 1 into the top and 1 into the bottom. So what we look for if something's not a special angle is, do we have a sum of angles giving 90 degrees? And if we do, then the chances are we need to use co-ratios to replace them. All right, so we're going to do some examples. Please remember, we're sticking to all the previous rules. Don't worry about your co-ratios until right at the end. So we're still going to start by identifying the quadrant. We're going to rewrite the angles. We're going to do the sine and reduce them. And then we're going to do our replacements with special angles. And only after that will we worry about co-ratios. Okay, so we're still going to be following exactly the same steps as we were yesterday. Okay, so here's an example. Sine 110 plus cos 200 plus sine squared 315. So the first thing I do is I identify my quadrants. Right, so this is quadrant. Sorry, I haven't got my 0, 90, 180. Hopefully by now you know these. 1, 2, 3, and 4. Okay, so sine of 110, that's between 90 and 180, so that's in the second quadrant. And in the second quadrant, remember, it's going to be 180 minus theta. Cos 200, well, that's bigger than 180, smaller than 270, so it's in the third quadrant. And in the third quadrant, I've got 180 plus theta on my diagram. And then 315 between 270 and 360, so that's fourth quadrant. And if you look at the fourth quadrant, there's 360 minus theta on my diagram. Okay, these you do not have to write. I'm just doing it to help you to remember to write your reductions, that's all. Okay, so I've identified my quadrants. So because these are numerical examples, I now need to rewrite my angles. So this is going to be sine of 180 minus what? 70 would give you 110. Okay, cos of 180 plus what? It's going to be 20. 180 plus 20 gives me 200. And then finally, sine of 360 minus what? 45 will give you 315. And remember that was squared. Okay, so that was rewriting. Okay, then 3, we're going to do our sine and our reduction. So let's see. This is sine in the second, so it's positive sine 70. Don't need that positive sign there, but you can put it in if you want to. Okay, cos in the second is negative, so now we've got a plus. This is the sign here. We're going to have a negative cos and reduce it to the acute angle of 20. Sine in the fourth is negative, so negative sine 45, and remember I'm going to put the square on the outside of the bracket. That square is now being written here once we reduce. Okay, what's after that? We've got to do our replacements. Okay, now I can see the only special angle I've got is this one here. The others are not special angles, so we don't worry about that. We just keep going. Replace your special angles. So this will be the sine of 70. I'm going to multiply these two together. Positive times a negative is a negative cos 20. And this will be positive. And then the sine of 45 from your special angle triangle, 1 over root 2, and I have to square it. Okay, now I can see that these two, I couldn't replace them, but can you see that these two angles, 70 plus 20, is equal to 90, which means I can either replace the sine of 70 with the cos of 20 or the cos of 20 with the sine of 70. So I'm just going to replace this one. So change sine into cos and then use the complementary angle 20. This one is going to stay there because now these are like terms, and this one is going to end up being square the sine. So that's going to be a positive square and square. So we get a positive 1 over 2. All right, so now these two are like terms. So we've got that one minus that one, which gives me 0 plus a half. Sorry, wrong color. So I'm simplifying 0 plus a half, which will give me a half. Okay, so you look for those co-ratios right at the end. All right, here's another one. So we're going to, same steps. Can I identify my quadrants? Okay, here I can't at the top, but I can at the bottom. This is between 180 and 270, so this is quadrant 3. And what I do if I can't identify the quadrants, I subtract or add 360 until I can. So that's my first step. So this is cos of 15. Now I can see which quadrant it's in over the sine of 255. Okay, so now I can see that this is 1 and 3. Okay, if it's in quadrant 1, leave it alone. Okay. We're trying to reduce to an acute angle, so we want a quadrant 1 angle. This is quadrant 3, so it says 180 plus. So now we're going to rewrite. So we're going to have cos 15 over sine of 180 plus 75. Reduce, remember your sign. So this is going to be, well, this is already reduced, that's why I say leave it alone. And this bottom one is going to be negative sine of 75. Okay, now do I have any special angles? No, 15 and 75 are not special angles. So then I look for co-ratios. Yes, 15 plus 75 equals 90. So that tells me I need to replace one of them. So let's just take the top one. So let's replace the cos of 15 with the sine of 90 minus 15. You don't have to pop the step in. You can actually go straight to sine 75. So replace the cos of 15 with the sine of 75 over negative sine 75. And then that divides into their ones and ones. So the answer is going to be 1 over negative 1, which is negative 1. Okay, so you only look for your co-ratios right at the end of the sum. All right, let's try two more quick ones just to get you used to them. So this, identify the quads. And if I can't, we add or subtract 360. Okay, so this is quadrant 3. This is quadrant 2. This I need to subtract 360 because it's bigger than 360. And this one I need to add 360 because it's smaller than 360. All right, so off we go. So this is tan. I'm just going to leave this for now. 240 sine of 360 minus 280 is 80. So now I can see where it is. And 370 minus 360 is 10. Okay, so now I can identify all my quadrants. So we said this was 3, 1, 2, and 1. Okay, so quadrant 1 you're going to leave alone. The others we are going to rewrite. So we're going to have tan of, what's in quadrant 3? 180 plus what? 60. Sine of 80, first quadrant, leave it alone. Tan of 180 minus 30. And then cos of 10, also first quadrant, leave it alone. Okay, so leave quadrant 1 angles alone. All right, and now we're going to do our sine and reduce. So we're going to have positive tan of 60, sine of 80, negative tan of 30, cos of 10. Okay, now we're going to replace our special angles. And the only special angles in this one would be the 60 and the 30. So quick. Okay, tan of 60 would be root 3 over 1. This is not a special angle, so I'm going to leave it. Actually, can I ask you guys to do this? Can you see here straight away? These two make 90. 80 and 10 give me 90, which means that I can replace the sine of one with the cos of the other. So I'm going to, at the same time, do my co-ratio. So I'm leaving the sine of 80 there. I'm going to replace the bottom cos 10 also with the sine of 80, because cos of 10 and sine of 80 are equal to each other. And let me go back to tan of 30 is going to be negative 1 over root 3, reading from my triangle. Okay, so I've used these co-ratios to enable me to cancel those. And we're going to end up with root 3 over 1. And instead of dividing, we times by negative root 3 over 1, because we invert. So you're going to end up with negative 3 over 1, which is negative 3. All right, so that's how we use the co-ratios. I'm hoping that that's been a little bit of a help and that you're going to be able to do some of those examples for me.